I'm so glad you're here. Thank you for coming. I want to take us on a journey through space and time and take a look at the clouds and how, as a community, we can actually have global reach and impact. This photo that you see on the screen right now was taken in 1960s. It's one of the first broadcasts from space. It's a television broadcast, and it's the first time we see clouds. This was taken a bit later. It's a pretty famous picture. It's called Pale Blue Dot. You might not be able to see it on your screen, but in that red band on the right, about halfway down the screen, 1/3 of that pixel is Earth. It was taken by Voyager 1. This is probably the most famous selfie in the world. This is all of us. It's taken in 1972. The picture is called Blue Marble. And it was taken by the crew of Apollo 17. We go forward in how we develop our technology and what we can do with our knowing the surface area of the Earth and the cloud coverage therein. This is 2001. We now have many satellites, and we can see the whole Earth within 24 hours. They combine those images together in a project called Blue Marble 2 from NASA. This is a day, a single day, with all of the clouds in place. This was done in 2002. We were able to remove the clouds and see the land and the ice underneath and the seas. We can remove the ice and actually see an actual image of the Earth. But what's important in all of this is the people that cover the surface area of the Earth. And that is why the CNCF is all about building sustainable ecosystems so that all of the things that we do together can run anywhere on the planet. The Linux Foundation, CNCF, is also about fostering communities. The Kubernetes community is an excellent example of one of the communities that the CNCF fosters. And through that community, we're able to take and benefit from the work that we're doing together so that we'll have production workloads worldwide. This is why we have Conformance. It's so that what we do can run everywhere. So I'm going to go back to the beginning of these pictures to kind of do a parallel of our journey on Conformance and where we can go from here. This first photograph is representative when we first got a glimpse of what we were looking at in the surface area of Kubernetes. We were just looking at the log files from running the EDE test suite, and that was done by Kenomichi. That work showed us that we were lacking a bit in testing all of the things that people could do with Kubernetes. We stepped back a bit and said, well, what other data do we have? We noticed that we had our audit logs that were getting generated. So we began to analyze those audit logs and publish what we found to a static website by hand. And I think our coverage at that point was somewhere around 14%. And 1.12, we started to get a really good picture of what was happening because we were getting a glimpse of actual test coverage. What happened in 1.12 is we added support in 2 areas. One was user agents were getting recorded by our API server in the audit logs. So we went and could look in the audit logs and say, who is talking to us today? And then we asked the EDE framework, when it communicates which test are you working on? And that allowed us to quickly say, of all the surface area of Kubernetes, which tests are hitting which endpoints? Particularly, which ones have we flagged for conformance? With 1.13, we were able to start seeing the changes over time because we could load the audit logs from our CI into a series for comparisons. We set up API snoop.cncf.io, and that allowed us to, and I'll show you that in a bit, to compare our coverage over time. It's hard to see all of this if you have all of the data, and being able to query, sorry you can't read that slide roll, but dynamically querying what's there. What we did, instead of having all the audit logs just in JSON form, we created the database. So we could ask and answer questions that we weren't sure of yet. And that's critical to asking the right questions and getting the right answers. With 1.15, it's been a really fun journey on that release because we had APIs that were getting promoted to GA that did not yet have conformance tests. And we have a policy where everything that flows into general available must have conformance tests. And this allowed us to identify precisely where our gaps in coverage were and to assist that team to do so. 1.16 gave us a new metrics of API surface and coverage. And I think the next part is what can we do now? We've got this increased ability to understand where we're lacking in coverage. But unless each of our SIGs finds the APIs that they're responsible for and help us get to that 100%, it's not going to happen by itself. So what we've done in this last release is make it so that you can actually run API Snoop in your own cluster. And as your applications run, or as your test suites run, you can see, did I hit things that are not yet covered by our conformance suite? Will what I'm doing run everywhere on the planet or not? The API Snoop interface is up at apisnoop.cncf.io. And if you want to run it on your own cluster, you can look at our GitHub repo or reach out to me. I'd love to meet with each of the SIGs to help you get to 100% so that all of the areas of functionality that your group brings to the world has tested so that everybody can be super confident that their workloads will run. If you want to get in contact with the Kate's Conformance team, we're on Slack. And we also have a GitHub repo at cncf/Kate's Conformance. Is there any questions? Or would you like to see API Snoop? It's going to be a bit tricky for me because I can't see that screen. So hit F11. And then I'll hit this. I'll hit F11. And I might come sit out there with you. Pardon me. So this is back at 112. And we could even go back a little bit further and look at a 111. If we look at 111, you'll notice when it loads that there was 0 conformance tests and 0 test hits. Welcome to demo. What happened in 112 is we added the ability to see what tests were hitting it so we could say whether they were conformance or not. So there's 111 loading. 0. But we didn't know we had 963 endpoints, which was nice. But conformance stuff has to be generally available, which means no alpha, no beta. So we're just going to focus on generally available, because I want a green, safe place to grow ideas all over the world. So if we drop down and we go from 111 to 112, you can see we now have 373 stable endpoints, and we're at 20% coverage for conformance test. And if we drop down, and these are CI buckets from our, used to be a release blocking job. So this is our endpoints coverage going up. And I'll go ahead and skip to the most recent stuff so that we can see where are we now and where do we go from here. I'm super happy to say that we have 100% coverage for stable admission registration. And this one over here, I believe. This one is 100% for stable API extensions. Our areas that we might lack a bit in, this yellow one is storage. We don't write a lot of storage tests yet because we don't have a framework in place for that. We need to get there at some point. Another one is auto-scaling. We don't have a lot of auto-scaling because it depends on some non-available metric server. So we can't hit that. But if we go over here, for example, to stable apps, I'll just focus on stable apps for a minute. Stable apps is at 26 point, it's only 27% covered. We have a lot of ground there, and we have specific endpoints that we should be able to hit. And this is part of our workflow, is identifying who knows best about these particular operations, and how can we work with them to ensure that there is a well-written conformance test so that that capability is available to everyone in the world. This is the UI for API Snoop that we have currently, but we also have an in-cluster version that you can compare what you're running against this coverage. So you can make that 100% for your SIG and your functionality. I encourage you to spend some time looking at our gaps and helping fill them in so the whole world can run Kubernetes clouds locally and conformantly. Thank you. Any questions? Oh, go for it. That's a very good question. So the definition of how we interact with Kubernetes is actually defined by all of our code and talking to the Swagger endpoint and saying, API server, dump your Swagger. So if you look in, I believe it's APIs and Swagger JSON submitted to Kubernetes. That JSON file contains the list of operations. There are 1,400 or so of them, and about 800 deprecated, 400 to 450 are non-alpha, non-beta. You're right. I believe it's important to do both, because if we don't hit them, other people will hit them. We made the mistake of saying, well, I forget the exact API that was there, but it was like PR number 4. It's really early on, and it said, please add this. And then I was about to write a test for it. I said, oh, something that's generally available and untested. And I think someone said, wait, that's old news. We don't need to use it. Let's just deprecate it. So I went to add a deprecation. And they said, no, wait, we're using that still. and so once we put things through that GA process, it's really hard to take them back. And so I believe it was, it's always like, we don't need to test just the CRUD. We need to actually have meaningful tests. And so part of what John Bellamaric is doing, we're working together to create this behaviors. So what is it that we do with Kubernetes, and making sure that that's able to be done everywhere. So writing meaningful tests. So what we're doing by measuring operations is giving us this base level. But to help define that, what we've done is we've turned the Swagger and go, what do we think coverage is according to this API definition? And the ability to query the entire set of anything that happened to the API server and come up with our own definitions of the denominator of what is it we want to, what's our goal? And then our numerator is how far are we along that journey. One of the other ways we looked at measuring coverage as a whole is by doing so by looking at the fields for each and every one of our kinds / object types. And I think when we looked at the full enumeration of that, it's 77,000 because it gets really deep and recursive, and it's great, but using both of those is just a baseline of increasing. So once we do fill out those branches, we just want to make sure we don't start pulling back testing. So what we'd like to do going forward is we kept open right now to take the numerator and the denominator as we have them defined and make sure that if somebody submits a new piece of code to Kubernetes, that it doesn't decrease our numerator or increase the denominator at the same time, as long as everything increases. We want up and to the right, right? Any other questions? Yep. Excellent question. So I'll repeat that for the mic. What's the difference between a test and a conformance test, and how can API Snoop tell the difference? So when I mentioned back in 1.12 that we updated the EDE framework to actually submit the full string of the test that it was currently running as the user agent. So it'd be like your browser saying, hey, I'm on this version of software and this is the person coming at all this. It's like cookies via the user agent data. We also added a patch to the Kubernetes API server where the audit logging included this user agent data. So when we have this database of all of the ongoing interactions, including running it live in cluster and being an audit endpoint now, you can say, I just want to see the stuff related to this test. And the difference between a test and a conformance test is two things. One, it has little brackets around the word conformance. And there's CI in place to make sure that can't happen unless it's in a file called conformance.txt in the test conformance test data folder. And the owners on that file is like 3. John, you're 1. Who are the other 2? Clayton, Mitchell. Yeah, Clayton, Mitchell, and Brian. So that's what it means to have conformance, because they have that's what conformance is versus a conformance test. Dems? That's an excellent question. When it actually tests that feature or functionality and it gets approval, what we've tried to do in the conformance working group is make sure that the people approving what the test does is by the experts in that field. Defining what should be conformance is for the SIG architecture to do. So we connect SIG architecture with the experts in all the different SIGs and make sure that this definition of what Kubernetes is well defined and tested. So to be a conformance test, it needs both. An example of a test that would never become a conformance test is something that tests something cloud provider specific. Because we are expecting this to run on every single, it's the requirement. It needs to get the badge, and we want everybody to get the badge. It needs to do what Kubernetes says on the box. It can't do something that AKS or GKS or take your all KSs, but it's got to be for everybody. So that's why I'm doing this, is I want to do the things that make what we do together available for the whole world, not just some of us. thank you for your time. If you want some help running and observing the behavior of your applications and seeing if what you're doing can be done all over the world, feel free to reach out to me. I'm Hippie Hacker, and I'm with II.